And hey presto, you can see that the variable encoded has taken on the value 11, 14, 13, just like our example. Cool. So we now want to create a script that will do the same thing, but for any word that it is given, not just for the word bed. Let's start by completing our code list to include all the other letters that we will need. We add the letters G through Z, then add in the numbers 0 to 9, and finally, to support Scratch usernames, we also add the symbols plus, minus, full stop, space, and underscore, remembering to press enter after each new letter. Letter added. Now make a new custom block, label it write, and then add an input named val. Now make a new custom block, label it write, and then finally add another label to encoded. So the full block becomes write val to encoded. Tick the run without screen. Refresh and click OK. We need a new variable named letter hash. Meaning letter number here. Now hold on while I build this script up. Then I'll explain how it works. If the input named val is set to Griffpatch. The length of val will be 10, as there are 10 letters in the word Griffpatch. So our repeat block will loop around 10 times, once for each letter. Letter number starts as 1, and then each time round the loop we add 1 to it. This means we can keep track of which letter we are looking at next. Finally, we do the same thing we were doing earlier. Find the item number of the letter in the code list we were encoding and join it to the end of the variable encoded. So once this repeat loop finishes, we should have successfully encoded all the letters in the input val. Let's try it out. First, set encoded to empty. And then write bed to encoded. Now click on this block stack. Should show no change in the value encoded because bed was also the last thing we tested our encoding on. So let's change the word to encode to be Griffpatch. Much better. It updates, that's brilliant. This is a good sign that it's all working. Now, one final touch before we move on. We will mark the end of our encoded word with a 00 to let us know that we've reached the end. This will allow us to encode more than one value by marking the end of one word and the beginning of the next. Simply set encoded to join encoded with 00. Great, we have our encoding script and it creates values that the cloud system will happily transmit. But this is useless without a script to decode the values again at the other end. We'll break this up into 2 custom blocks, one to begin the decode and the other to read out the values. Start by adding a new custom block called begin decode of and add an input of encoded. Run without screen refresh and OK. Set encoded to the custom blocks run without screen refresh and OK. set encoded to the custom block's encoded input, and set letter number to 1. Add a new second custom block called value equals read from encoded. Run without screen refresh and OK. Make a new variable named value for this sprite only. And add a second new variable named idx, and again make it for this sprite only. As before, let me quickly put this script together, and then we can go over how it works. OK, the variable value begins empty, but we are soon going to fill it up as we decode from the values held in the variable encoded. We use a forever loop here, but notice the stop this script block with within the the loop. This ensures the loop will not actually run forever, but stop when we want it to. The first thing we do in the forever loop is to take the first two letters from the variable encoded and stuff them into the new variable idx. This will give us the first pair of digits that represent a letter to be decoded. We then move on our letter number variable so that it will be ready to read the next pair of digits when we need them. See how we're moving on by 2, not 1, because we are always reading the digits in pairs. Now we check to see whether we have finished reading in the full word. IDX will be less than 1, both when it reaches 00, or if there's no more letters to decode, so this is a very good safety net. If we have reached the end, then simply stop this script here. Make sure that it is not a stop all scripts. Lastly, if we have not reached the end, then we look up the letter represented by the 2 digits in our code list and join it to the end of the variable named value. The loop then repeats again, reading in new letters until we do indeed reach the end of the word. Great, let's test this decoder. Drag out the new custom block, value equals read from encoded, and put it under the begin decode block. Now click it. Yes, you should be seeing the word bed appear in the value variable. If so, then I'm so happy. Well done for following the script so closely. I know these are a bit tricky. Let's try it again for another word. Griffpatch. Click to encode. Click to decode. Great. But watch this. There's more to these scripts than just encoding a single value. Let's duplicate the write block from our test and encode two different values, 1, 2, 3, and then 4, 5, 6, one after the other, and then click to encode them both. We have now encoded both these values into the same encoded variable. To get these values back out, we first separate the begin decoding from the value read block. Here and click the begin decoding block. Next, click the read from encoded block, and we should find that the value has become 1, 2, 3, the first of our encoded values. Click the read block again, and we get 4, 5, 6, the second value we encoded. Perfect. We are making great progress. With these custom blocks defined, we are well on our way to making a better multiplayer script. Let's clean it up a bit. We don't need these test blocks anymore. Now scroll back to our original cloud scripts. Let's have some fun. I feel we've earned it. So previously, we were storing two values, the mouse X and Y, in two cloud variables. This is just not good, as we've shown. So instead, we now use our encoder to write them into a single encoded value. Start by using our write to encoded block. Oops, almost forgot. Don't forget to set encoded to blank before that. And we want to write out two values to encode. So duplicate the write block, and we write the values of mouse X and mouse Y. Now that we have these as a single encoded value, we only need a single cloud variable to store it in. Let's create a new cloud variable called just P1 for player 1. Drag in a set block, setting our cloud variable P1 to the value of encoded. So let's swap out the old code for these 4 new lines. That's the encoding taken care of. We now need to rework the decoding script below. Bring in our begin decode of block and drop in the value of the cloud variable P1 for decoding. Now because we decode one value at a time, it'll simplify the scripting if we now use a setx2 block here. Let's decode the x position from the cloud variable using our value equals read from encoded block, and then set x to the decoded value. Now duplicate the last 2 blocks, and we'll do the same for the y position. Don't forget to to swap the setX for a setY block here. Now, the first moment of truth has come. If our scripts work, then we should still be able to run this project and have the cat follow our mouse cursor. We press the green flag with the mouse, and then tap the number 1 key to assign us to be player 1. And look at that, success! We can see the player 1 cloud variable updating, and more importantly right now, the player position is correctly being decoded so that the cat is again following our mouse. This is great news, so our program is working so far. But this is now the second moment of truth. Let's see if it works across web browsers. As in my previous video, I open a second incognito web browser and load up the same project in my Griffpatch account. Click the green flag on both projects. Then, clicking into the left-hand page, I press the 1 key to activate it as player 1. Moving the mouse around, you can see that the position of the player is mirrored far more accurately now than it was in the